Wow, look at this kid go down the hill. That's pretty amazing. That's a steep slope. You guys know what slope means. A lot of you think of it as going up or down a hill. A hill has a slope. But we talk about slope in math too, and that's what we're going to talk about today. As you go through this lesson, you'll come to some You Try It slides. When you get to these, hit your pause button, do the problem, and then hit your forward key to go on to the answer. Now let's watch this guy's jump. Pretty awesome. This is math, remember that, so we got to find a number to represent slope. And we've done that. And there's a formula to figure out that number. Slope equals rise over run. Slope equals the amount it goes up and down, which how much does it rise, over how much does it run, the amount it goes left and right. In this case, this hill that this machine's trying to chug up has a rise of 40 feet. It goes up 40 feet. And it goes up 40 feet over a run of 100 feet. So the run is 100 and the slope equals 40 over 100. Oh yeah, again, this is math, and we got to have a symbol to represent the word slope because we just don't like to write out great big words. So we pick the symbol M. M equals slope. And in this case, M equals 40 over 100. If I divide 40 by 100, I get 0.4, and the slope of this hill is 0.4. Well, we could also determine the slope of a line that was on a coordinate plane. And we do it pretty much the same way we just calculated the slope of that hill. The formula is slope equals rise over run. And rise is up and down, and run is left and right. Well, on this line right here, what we want to do is pick 2 points. And we'd like to pick points where the line crosses two intersecting grids. Up at the top here, I got a grid there and a grid there, and they cross right about there. And down here, I've got another place where the line crosses the intersection of two of the grids. So let's use those 2 points. And let's start up here and figure out what the rise is. 1, 2, 3, 4, 5, 6 in a negative direction. So the rise is minus 6. And the run, 1, 2, 3, also in a negative direction. So the run is minus 3, and the slope is minus 6 over minus 3, or 2. How about this line over here? I've got a couple of points marked off for you on that. And let's start with that one and find out what the rise is. Well, it's an 8 in a negative direction, so our rise is minus 8. And we calculate the run, and it's also 8, but in a positive direction. So it's positive 8, and the slope is minus 8 divided by 8, or minus 1. Now here's an important point. You can see that that line in the blue up here is going from the lower part on the left to the upper part on the right. It's sloping up to the northeast of the coordinate plane. And it's got a positive slope. This line, however, is going the opposite direction. It's going from the bottom left to the top right. Excuse me, the bottom right to the top left. And it's got a negative slope. And that's always going to be the case. If a number's got a positive slope, it's going that direction. If it's got a negative slope, it's going that direction. There's another way we can figure out the slope of a line, and that's with using the coordinates. You remember a line crosses a lot of points, an infinite number of points on a coordinate plane, and each of those points has a coordinate pair that represents its location. For instance, that point right there is at an x of 5 and a y of minus 3. And this point up here has an x of 1, 2, 3 in the negative direction, and a 1, 2, 3, 4, 5 y in the positive direction, minus 3 and 5. And we can use those coordinate pairs to determine the slope of this line. And the formula for doing that is listed right up there. Now, I threw in a funny symbol that most of you probably don't understand. It's that triangle, which is a Greek letter called delta. So I've got delta y over delta x. And all that delta means is the difference, the change in. So I'm going to get the change in or the difference in my y's, and then I'm going to get the difference in my x's, and I'm going to divide those two numbers, and I'll get the slope. Let's get the change in the y first. The y went from a 5 to a minus 3. So I subtract to get the difference. I subtract 5 minus 3. And then my x's changed also. I went from a minus 3x to a positive 5x. So I've got minus 3 minus 5. Well, 5 minus 3, if I subtract a negative number, it's just like adding. So 5 minus 3 is the same as 5 plus 3, or 8. And minus 3 minus 5 is minus 8. I've got 8 over minus 8, which is minus 1, which is the same number, of course, that we got when we did it by counting rise over run. We can also calculate the slope with a table. You remember we were using tables in order to graph linear equations in the last lesson. Well, we can use that same table to figure out what the slope is. And I've got a table up here that represents the line that is shown on the coordinate plane to the left. And we've got an x value, and I just picked minus 2, minus 1, 0, 1, 2, and 3 for x values. And then I calculated what the y values are. Y equals minus x plus 2. Well, if x equaled minus 2, y would equal minus 2, or positive 2, plus 2, which is 4, and so forth. Now, if we're going to try to figure out what the slope is using the points in this table, we need to kind of pick arbitrarily 2 points. So I picked that and that. And those represent, that 1, 1 represents the coordinate pair of one of the points on this line. And this minus 2, 4 represents the coordinate pair that describes the location of one of the points in the line. But we can use this table to figure out what the slope is. And you remember the slope is the change in y over the change in x. That's really the same thing as rise over run, because y is going up and down, that's rise, and run is going left and right, and that's the x-axis. So we just pick one of the y values, and there's a y value, and then we subtract the other y value to see how much it's changed. So I've got 1 minus 4. Now we do the same thing with x, because x is run, and so we pick the same pair. That's 1 minus 2. 1 minus 2, excuse me. So 1 minus 4 is minus 3, and 1 minus 2 is positive 3. And our slope is minus 3 over positive 3, or minus 1. All right, here's a couple other things about slope that you ought to understand. The first is with parallel lines. If I've got a couple of lines, I can tell if they're parallel by determining if their slopes are the same. If the slopes are the same, the lines are parallel. Well, let's get the slope of that line first. It's got a rise of 2 and a run of 2, so the slope is 2 over 2, or positive 1. Now let's get the slope of this line, and I went the other direction. I had a rise of minus 2 and a run of minus 2, and minus 2 over minus 2 equals 1. Both of those lines have the same slope, so they're parallel. Here's a second thing that you should probably understand. The slope of a horizontal line is going to be 0. And I think you'll see why in a minute. If I pick any point in that line, like right there, and I try to find out how much the rise is, well, there is no rise. It doesn't go up, it doesn't go down. It's a parallel to the x-axis. So the rise is 0, and then I can put in any x value. Doesn't matter, because 0 divided by anything equals 0. So the slope of a horizontal line. Now you try this one. Hit the pause button, do the problem, and then hit the forward key to move on to the answer. To find the slope of this line, I've got to find 2 points on the line, and preferably 2 points where grid lines cross. So let's pick that point right there and that point right there. And first I got to calculate the rise. Well, it rises just 1. And that's positive. And the run is 1, 2, 3. So the slope is the rise of 1 over the run of 3. And you could call the slope 1/3, or you could turn it into a decimal and it'd be 0.3 repeating. Hit your pause button, try this problem, and then hit the forward key to move on to the answer. Well, you recall we can use a table that represents a linear expression and calculate the slope of the linear expression, or the slope of the line from that. And the first thing you got to do is kind of pick 2 coordinates. And I picked -3, -12, and -4, -14. And then the formula is change in y over change in x. And change in y, the y-axis runs up and down, so that'd be a rise, and the x-axis runs left and right, so that'd be a run. So change in y over change in x is rise over run. So what is our change in y? Well, let's start here at -14 and find out how much that changes to get to -12. -14 minus -12, if I subtract a negative number, it's like adding a number, so -14 plus 12 is -2. Now let's get the difference in the x's, and you got to start at the same coordinate point. So we're going to start with -4 minus -3, or -4 plus 3, and -4 plus 3 is -1. Now I just got to simplify that. -2 over -1. 2 divided by 1 is 1, and a negative number divided by a negative number is a positive number, so our slope is 2. Try this one. Hit your pause key, do the problem, and then hit the forward key to move on to the answer. Okay, our slope is the rise over the run. So I pick a point and I figure out how much it rises. 1, 2, 3. So it's a rise of +3. Now I got to go back over to the line from that spot. I go 1, 2, 3, 4, 5, 6, 7, 8. And that was in a negative direction towards the negative numbers. So it's +3 divided by -8, which equals -0.37. Well, I hope you learned something. Now it's time to find out and test your skills at www.mastermath.info. Download the worksheet under 8th grade entitled Slope of a Line and try your luck. You can also try the interactive self-grading test at www.mastermath.info. It's also labeled Slope of a Line. Well, I hope you had a good time, and you'll come back again real soon.